Hey, and welcome back to another Kubernetes episode. In tonight's video, we're going to be looking at some AI stuff, particularly around Kubernetes. AI has picked up quite a lot in the last year. There's a lot of toolings coming out day to day, in lots of different areas, especially in the technical industry. You've got day-to-day tooling for, picture creation, people utilizing that picture creation software to create books on Amazon and sell them. You've even got stuff for software engineering that would help with, managing code, improving code, refactoring code. And in particular, for me, I really wanted to see some of the stuff around cloud engineering, in particular for Kubernetes, right? I really want to understand if we can leverage GPT to handle cluster issues, not necessarily, making changes, but purely around knowledge aspect, providing information to someone who doesn't know Kubernetes. Because if you don't know Kubernetes, it can actually be quite scary at first. So I've actually found a tool called K8sGPT Operator, which is a tool that lives inside the Kubernetes cluster, listens for events for things like crash loop backoff, particular issues that you would naturally see with the cluster. And then it reports it back into some sort of like JSON result, which is then utilized for, people that really want to understand what's going on with maybe their service inside a Kubernetes cluster. Deploy this operator to our cluster. So I have a cluster running in DigitalOcean already. Yep, I do. I should be able to get the namespaces. Yes, I do. So there is a repository called K8sGPT. Now there's two kind of toolings here. They have a CLI, which you can utilize to interact with your cluster to provide back data that would obviously be outputted by GPT. Or you can deploy an operator that lives inside the cluster and essentially listens constantly and does a load of reconciliation to provide the events back from a cluster. In this case, we're going to deploy the operator. So I've already done these two bits for Helm where we add the repository. So we're just going to do the deployment first. So I'm going to change the namespace because it's a bit too long for me. So first of all, I'm going to create a namespace. In fact, no, let's just take this line. I could create the namespace myself, but considering Helm's going to do it anyway, we might as well. So we'll call it K8sGPT for short. And we'll call the release K8sGPT. So that now will install the controller and likely the CRDs as well, if there are any, which I assume there are. And if we look inside the namespace, we get the operator for K8sGPT. Cool, it's running. That's a good start. So then what we need to do is we need to be able to create a secret with the OpenAI API key, which we get from OpenAI. We have to generate it. In this case, I will be generating one and then destroying it afterwards so that no one can use my token, considering the billing. So we'll create this secret first. And again, I don't mind this token being shown now because it's going to be destroyed after. So we need to create this secret. So in here, we will go to API keys and we will create a new one. And we'll call it K8sGPT blog. We'll create the API key. We'll take it and we'll paste it here. And that should create a secret. And we can see that if we list the secret inside K8sGPT namespace. Cool, that's a good start. Then what we need to do is apply the K8sGPT resource. So you can see this is kind of customizable. You can send some data to Slack if you wanted to. In this case, we're not going to be doing that. We're actually just going to be deploying it and looking at the events. So we don't need to specify repository because I think that's been removed in the latest release as part of the CRDs, so it would fail. But we are going to enable the AI. We're going to use 3.5 Turbo. Backend will be OpenAI. We'll utilize our secret from the secret we just created. And we'll use the version 0.3.8, which I believe is the latest version. So, oops, we need to update the namespace. I forgot about that. It's actually K8sGPT because for that. Cool. So now if we look at the pods, we can see there is a K8sGPT deployment pod. There's the operator, which would do a lot of reconciliation on that pod. Or at least, sorry, it would do a lot of reconciliation across the cluster, looking at events for certain issues, and then the K8sGPT deployment does a load of stuff with OpenAI to basically fetch a load of data. I haven't really fully understood what it does yet behind the scenes when it goes to talk to OpenAI. My assumption is it is the controller manager, or likely the operator, takes out all the events from the cluster when it comes to errors, and then that deployment takes all that information, consumes it, and kind of talks to OpenAI to bring back a nicely formatted, AI result that would be more self-explanatory to an engineer, for example. So if we look at logs, we can see that it's binded. It's done a couple of requests to OpenAI, but at the moment we've got we actually don't have no issues. We've got nothing. Everything's running fine. So in this case, if we look at what it provides back with the results, I'd expect something empty, which is right. So we're going to have to deploy a couple of dummy pods to break it. Well, not break it, but provide some information back. So there is a repository from Robusta. If you haven't heard Robusta before, they provide some insight for monitoring, and they also utilize GPT for a lot of monitoring as well. So you can actually ask commands in Slack when it comes to understanding certain things like, crash loop back off, out of memory kill, CPU throttling high. So we're going to deploy a bunch of these into our cluster, which would simulate crash loop back off. So we'll deploy that one, and then we'll deploy the pending one, and then we'll deploy image pull back off. I think that's enough. So we should get crash loop back off, pending, failing to pull the image, and so on. We could deploy more, but I think this is more than enough. So as those have deployed, we now need to check our pod. Just want to see what's happening if I check the logs to see if it's picked up anything. K8sGPT. Okay, cool. It's still querying OpenAI. Now I just want to check the controller manager as well, based on my theory earlier around the reconciliation of checking events. Okay, so you can see here, create result for default example pod, finished reconciling K8sGPT. So my assumption is now I would expect to see more eventually when the reconciliation kicks in again. I'd expect to see some more examples, but if we look at get results now, we get back some information. So you can see here, it's generated a result, and it's generated a result in particular around, I think, the pending one. So default example pod. So let's just take a look at that. Get PO example pod pending. Yeah, cool. So it's picked up the error from the cluster, and then it's utilized GPT to provide back some level of format, I think, or to give an understanding, right? So error 02 nodes available, 2 nodes didn't match pods node affinity selector. That's just kind of something we would see inside Kubernetes events. Now what GPT does, it will kind of try and provide a solution. So one of the solutions is, it says check node affinity selector for the pod, ensure that the nodes match the pod's affinity selector requirements. If preemption is enabled, consider disabling it, as it is not helpful for scheduling. If preemption is not the issue, check if there are any other scheduling constraints or issues with the nodes. If needed, add more nodes to ensure availability for scheduling. So, that kind of gives you a pretty good understanding of why the pod is not scheduling. In some aspects, for someone like me who's a cloud engineer, I would know what to do directly, automatically, because I understand Kubernetes. But for someone who's just joining, or who is picking up on Kubernetes and understanding some of these things, the solution really helps give them an understanding around why it's failing, and kind of what to do. So we have a look now just to see if it's picked up some more. Okay, cool. So reconciliation kicked in again, and now it's generated a few more for the crash loop back off and no image deployment. So again, if we generate the results, we get a bit more. Cool. So now we've seen pending. We're now looking at no image deployment. So if it fails to pull an image, the error code while trying to pull an image, no such image. Solution: check the existence and availability of the image repository or registry, noimage.com. Step 2, verify the image name, no such image. Step 3, ensure the proper image name and repository are specified in the Kubernetes manifest or deployment configuration. So again, AI has, taken that information and tried to provide an easy way to understand why it's failing. So in this aspect, a user or an engineer would be able to go look at the manifest and just determine that no such image is correct as a URL for the repository to be able to pull the container down. In further aspects of things, when it comes to CI/CD, if you think about Semver releases, might be the case that there could be a mechanism that is broken there. So when someone pushed it and then tried to deploy it and it failed, that would determine some sort of error, at least, so people would be able to, engineers would be able to diagnose that. So if we kind of go on then, just a couple of more. We got any more? I think that's it. Example pod. There we go, back off. Right. So for the last one, for this demo, didn't know that happens. That's quite cool. So crash loop back off. So one of our pods was in a crash loop back off, and we didn't understand why. So in this case, it tells you the event from Kubernetes of it's in a crash loop back off. And the solution is to troubleshoot the issue, follow these steps. Check the logs of the container for any error messages. 2, identify the cause of the container failure and fix it. 3, if the issue persists, ensure that the resources allocated to container are sufficient. Use the Kubernetes CLI or dashboard to monitor the pod and check its status. Repeat the steps until the container successfully starts without any failures. So those are just a few examples of the GPT operator and what it can provide when it comes to an AI-driven, an AI event-driven report for cluster issues. For anyone that's anyone that's new onboarding onto Kubernetes or wanting to understand Kubernetes, this would really help a lot. And this also helps for a lot of engineering areas where if you have monitoring, things like Datadog or Grafana with Prometheus, or even Robusta itself, you'd be able to basically attach this kind of information to an error. So if a pod had failed and you sent it to Slack, you'd be able to kind of bring this information in and make it easier for an engineer to understand why their application is failing. Cool, so that's K8sGPT. I hope you enjoyed the demo, and Kubernetes doesn't have to be hard, or at least it doesn't have to be hard for users now who are learning Kubernetes. And even a business aspect, if you have a platform, a PaaS, for engineering, this is really good for for knowledge learning. So this is just one step to AI, I guess. There'll be more in the future when it comes to Kubernetes, maybe on a kind of proactive level. Maybe AI will be able to fix things for us in some aspects, like you kind of already get some level of self-healing with Kubernetes. Maybe we can go one step further with AI, I don't know. But I'm pretty excited to see what might come. Thanks for watching, and I'll see you in the next one. Bye for now.